Well, hi, good morning. Thank you for joining me in my shop. Today is September 23rd, and I have to tell you, I had trouble sleeping last night thinking about this radio. I'm so blown away that it operates. It's amazing to me. Now, I didn't listen to it very much yesterday. We just kind of quickly zipped around a bit here and there, so I think I'm going to start today by playing this radio, hooked up to a good antenna, go through all the bands, fool around with the different features, get a feel for what's going on, and keep it operating for a period of time. See if something fades out or distorts over time. The capacitors in this radio have to be leaky at this point. How can they not be leaky, for crying out loud? But the leak may be unimportant in many cases. It doesn't matter that it's a little bit leaky, but in others, a little leak can lead to trouble. One of the areas that commonly gets into trouble in most radios, we're going to check this one right now, is the output tube is often driven from the tube before with the capacitor protecting the grid. Here we are here. You can see here's the grid of the power tube here, and here's the line coming from it, and there's the capacitor I'm talking about. So a small leak in this capacitor, which is almost certain to be happening, is going to cause problems on the grid of the output tube. Can't be sure without testing it, but I'd be surprised. But here's the thing. I'm really more interested in using the phono output than the output from this tube or even this one. Now here's the phono output. And it's connected. Looks like it's uncontrolled. The volume controls here. You know, my copy here is really bad, but you can see the phono output. Oh wow, is that really an output? If it were a phono input, you know, I read that this is not. You're not going to hook a record player up here. That this really meant an audio output. Well, I guess it could function either way. I guess it could. Well, we're going to try this as an output. If this works as an output, which I think it will, an uncontrolled output, then I can pull this tube and pull that tube, not worry about the grid potential, all that kind of stuff. And you know, my objective here is to make sure the radio is in safe operating condition, which means operating it is not damaging it. I'm not interested at this point in making it work really well. It seems to be working really well as it is. But safe operation is really what I'm after. Oh, we wanted to look at where this output's coming from. This could be the same. Because I'm in the headphone output. Let's look again here and see. Can we find where the headphones plug in? Out here. So the headphones are driven from the output transformer. And none of this is going to work, so the headphones won't work either if I pull those tubes, which I very much intend on doing. The other side benefit, or minuscule benefit, is it cuts back a bit of the load on the big transformer here, because there'll be 2 tubes less to heat in the radio. Okay, phono output test. Okay, I've got to change my wiring a little bit here because it's just some screw terminals on the back. Okay, I will attend to that. Okay, got a piece of wire here, but I became concerned about the grounding situation. So if we look at this again, we see the phono input. One side is going to the chassis, one of these screw terminals just going down to the chassis. And the other side is the one that's heading off into the radio. So clearly I have to make sure I get the ground on this side here. Now, is that marked? Is it marked? I don't remember seeing a mark on the back of this showing that. Here's the phono. It's not marked, but we can certainly figure it out pretty quick. As quickly as I can find. voltmeter here. My multimeter. Multimeter. It's a multimeter. Okay, who's grounded? That's pretty clear who's grounded. One on the left. Oops, is the grounded one. Okay. I've got this cord. It's not quite the right kind of cord, but it'll do. It's miles long though. Well, maybe that's an advantage in here. 15-mile long piece of cable. Bet you these have never been unscrewed since the day somebody screwed them down in the factory. The weather here today is lousy. Another gray, ugly day. My wife and I had a vacation trip planned for today and the next few days. We canceled it simply because the weather is so bad. Okay. So there's a meter adjustment here, and the meter did not work yesterday, I noticed. Let's take a little look at that. So we're just looking at the back of the meter here. That looks a little cockeyed to me, like it's twisted. Somebody's written something here. Wires are hooked up to it. That's about all we can say. Excuse me. I can easily put another meter on here and look for voltage that's happening. Maybe it's not reflected on that meter. Ooh. Yeah, spinning this big radio around on my bench can have a bit of a clearing effect if I'm not careful. Okay, we're hooked up on the red. Because this happens to be a stereo cable. Here's the red. Okay. So I'm just plugging this into my own sound. Uh-oh, I need a very particular kind of plug I happen to have in my pocket. Yeah. Okay. Got the red one here. We're going to go on this knob here. Okay, first of all, headphones please. Let's just listen to what is going on here. Okay, so I'm hearing what you're hearing. Ooh, that's coming right out of the, that's from the connection I made to that radio. So the radio, let me plug it back. Yeah, I can't. How come it's buzzing with the volume down? Because this is set to, no, it's set to line. What's happening here? Oh, okay, let me just, let's try that again. Very buzzy. Some ground problem here, or maybe the wire's open. Well, that didn't work. Yeah, That didn't work. Okay, I'm a little surprised at that. When we're in the headphone jack or using a speaker, we're isolated from the radio. How isolated? Let's just see. How isolated from the radio? You see, the headphone jack has a ground, but the speaker outputs are fully isolated. Or are they? We've got a wire coming down here. Meter adjust. This will be the audio. Meter adjust. And what's this other line doing? Meter switch. Okay, we're getting out. Now, one of the reasons we could be getting a hum is this radio is not actually plugged into a grounded outlet. If you take a look at my little power box here, okay, over this way, you can see that the ground terminal of the little box is sticking out here. It misses the extension cord. So I'm only feeding the live wires, if you like, the grounded and the live wire here, the neutral wire, I'm not sure what to call it. The actual green ground wire is not making it here. So even though I've got a 3-prong plug, there's nothing grounding here. The third prong on this cord going to the radio here is tied right to the chassis. But you see it's just hanging open. In fact, the whole thing's hanging open here, except I've got it connected to the antenna. The antenna is a grounded system. So I'm a little curious about where this hum is coming from. It's just possible to turn the radio on and the buzz will go away. I kind of doubt it, but that's what we're going to find out. It's a little bit disappointing, actually. I did not expect, big hum back there. Okay. I think we're just going to have to start it up and see what happens here. The volume is the volume's not controlled by this knob anymore. The volume is set, basically. It's going to come out maximum. Do not have it plugged into my soundboard because it hums even if I just plug it in with the volume down. So we'll start the radio up with nothing. That's not a good idea. That's not a good idea. Let's start it up with the old way of listening to it. The old way. The old way, since yesterday. It has become the old way. Okay. Okay, this is the old way. So hum there. This is coming out of the headphones. And the other one's not plugged in because as soon as I plug it in, it hums too much. So, I still haven't investigated my camera. I get control over this automatic zoom feature. Okay. So I think we can start here. We will turn, let's see, power is off here. Power is on to the outlet. 113 volts today through the dim bulbs. Turn the power on here. You'll see the dim bulbs come on and probably come on pretty bright. And then they should go down. Down they go. 60 volts. Okay, I think we can just go for full power here. And volume up. And volume up. Because this volume does work on the his came in. We're on ABC, but we need this up a bit, I think. Here we are. We're on a broadcast band. We had a station here yesterday. What's different here? And the volume up. There's a microphonic vacuum tube or some component. Now we're not getting anything today. What happened? What's happening here? Something funny is going on. Well, we've gone past a number of places where I got pretty good stations last time. Band? What's happened? CW? It's not high enough. Put a rate up. Hey man, what happened to you overnight? Floor here. Funny behavior of the volume control. Let's go up. Way up. And down one. Just not sounding the same. Doesn't seem to be anything here. Mr. Radio, what happened to you? What voltage are we on here? 107 volts. Well, this is not what I expected. Just wait for something to suddenly change. That won't do it. Did not turn the antenna on down here? Maybe I made a mistake. Wow, I'm in tears. Okay, lots of problems going on here aside from the radio with my audio system. So I'm down to one microphone in mono. Okay, let's try this guy again. I have no idea why it didn't work. Okay, let's go. So we're listening through here now. That's me going the volume up and down. Definitely a hum involved. Here comes the radio. You could hear another deeper hum come in as the radio began. Amplifying. Okay, that if you heard that, that was my stomach. Okay, we're up around 16 megahertz. There's just nothing happening here. Why nothing? Well, there's something going on. A hum. Okay, if we change bands, do we hear clicks and pops? A little bit. Okay, I'm on the broadcast band now. Oh, I got this turned up. That's a mistake. Go down to the lowest band. Right here, there should be a station. sounds like the local oscillator is not oscillating. That's what it seems like to me. Because, let me turn this down, because, ooh, what the heck was that? What was that? Oh my gosh, what's going on there? Don't touch anything, just wait. I guess you can hear my cat meowing. Yes? Yeah, not right now. So what did this just start up? So a real noisy volume control like that, it's either because I got the volume really high over here, or there's DC going through this volume control. Wasn't doing that yesterday, was it? Whew. Sounds like it's getting worse and worse. Oh, smoke coming out, smoke coming out, smoke coming out, smoke coming out, quickly, 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 smoke coming out of there. Smoke something. Well, that's a sad situation now. Okay. Okay, I know, like 50 of you are saying, I told you so. Oh my gosh, where did that come from? It's coming right out of this can here. Right out of here. Right out of the bottom down there. Okay. That's a bad thing. Bad thing. That's a bad thing. Shame on me. Shame shall be cast upon me. So, that's bad. How many times I can say that? Oh, I feel so terrible. It's still smoking. There's still smoke coming out of it. How can that be? It just got cooked up so badly. So, there's a chance the coil is overheated, but it has not stopped working. Capacitor probably shorted out in here, and that's what's probably caused what has happened. Can you just come over here, cat, and get off my schematic here? So I gotta leave the shop here. It's full of smoke right now, but that's bad. Shame on me. Yeah, somebody needs to come here and kick me right in the ass for this. So, with any luck, I have not burned the coil right out. Yeah, I'm gonna go and commiserate with my cat. Okay, terrible. I know, I told you so. I told you so. Okay, the panic has subsided in me. My gosh. So there's quite an odor in my shop here, and it reminds me of resistor. A burnt resistor is what it smells like. Maybe I'm lucky here. Maybe that's all it is. But we're going to take a look, provided I can get my camera in here. I'm going to need to use another camera because we're going to have to take this top off, take the box off here, and then take a look down inside. Let me switch. Let's switch to another camera. Yes, yeah, I knew I was gambling, but I thought I would win the gamble. But apparently no, did not win the gamble. I guess what this says is it's a pretty clear message that don't operate this radio until all the capacitors are out. But wait, let's take a look at the situation here. And we'll see about getting these. The screw is loose. Seem to have lost my ability to operate a screwdriver, so I'm using the big screwdriver to loosen these, but then I have a gripping screwdriver to pull them out. Actually, you know what we can do here? I will loosen them right out. I'll just use a magnet to grab them. So yeah, so this is the nightmare of operating an old radio with old capacitors in it. That capacitor will short. Not necessarily a capacitor, but almost certainly. A capacitor will short, and then something will carry too much current and burn up. Screws before they disappear. Oh, one of them's already disappeared. Where's this one? Fell through. No, I got it. From the depths. Okay, what are we going to see here? Don't see much of anything yet. Probably down under is where the parts are, so I'm going to grab the camera here. We'll snoop around. Oh my gosh. So this one, see the shaft here. This is the crystal phasing control. I had this in a non-crystal position, but that didn't matter. And you see the crystal phasing control goes right into here. Never looked in this little box before, I don't think, in my other radio. I did the capacitors that are in here, I've done in my other radio. I think there's some capacitors in here. I don't see any in this thing. And it's just reeking here. I'm really having trouble being in here. We need more light on the subject. Well, that looks like a great big capacitor. What is that thing? What are these things? Maybe that, well, that's the crystal, isn't it? More light, please. I'll just do this. The camera's having a hard time focusing. That's okay though, it's actually helpful. Well, all I see is what looks like a crystal there. I don't see much of it. Oh, I see the burned resistor. There it is. There he is. That's it. There's a good chance that's the only thing that bit the dirt. Now, that's a 2-2, who knows? A 2-2 burned. 22 something. Now, why would this go? Because it drew too much current. Why would it draw too much current? Somewhere there's got to be a capacitor that is responsible for this. Let's see if we can figure some stuff out in the manual. I'll study up and then I'll show you what I found in the. Okay, let's see if we can make some sense of this. Oh, it's so bright in here. 3.5 megacycle crystal oscillator. Here's the can. In the can is 100K. Oh, 22K. There it is. It's shown in parallel right across the crystal and the grid. Now, how could this thing burn? What's coming in on this line? Over, up. So what they're doing is that they're tying together the grids of the oscillator tube and the mixer tube, or well, yeah, the mixer tube. That's a common thing. Why would this burn? Let's follow that line again. It's just straight to the first grid. There's nothing else on it. There's nothing else on it. Well, is there another 22? There's a 20 here. Inside the can. That would be two. That would be red black. The thing I saw was red. There's no doubt about it. On the grid. The tube shorted. 6E4. A short in the tube. Really? Really? Is that going to be the case? So this is vacuum tube number, what is that? Is that 8 or 6? And what a reek in here. Vacuum tube 8. Wacko. 6C4. This is the one I just put in. To the tester with you. So if it turns out the tube is shorted, you can't blame me for that one. that's not something anybody banks on. I think we're on the 6C4 right now. 6C4. Just checking. 6.3 signal level 2 20H 307 6P 3076P 5100 44F. Now I think we can guess certain tubes are prone to certain kinds of problems. I wonder if this tube is prone to shorts, internal shorts. Didn't I do one of these tubes and see a little bit of a short and went, ooh, that's probably okay. Didn't that happen somewhere along the line? Okay, here we go. Let me just do this. And then that's not what I wanted to do. What I wanted to do is this. Okay, then stand still. Otherwise the light will come back on. Because you can see the pointer now. I moved too much. Okay, that takes care of that light. Here we go. Shorts. Watching the meter. No shorts indicated in this tube tester. And testing 6C4, I can hardly see here, 1430, so right up halfway, over halfway. Hey, what happened here? Tube's not, okay. Let's just do this again. 6.3, 2, 20H. Three 3076P, 3076P, and 5100, 5100, 44, F. Everything is correct. Okay, the tube is not heating. Could just be contact here. If this tube didn't work, like if the heater shot in it, see, I'm watching the pilot light here. It's not flickering. Oh, what happened there? Okay. This shouldn't be going up at all when I'm doing this. Something a little funny going on. Something funny going on here, but this tube, oh, it is heating. Not very much though. Now it's good. Now we're good. No shorts appearing. Phooey. I was kind of hoping. I was really hoping that that would be the case. Some kind of short in here. Blowed it up. And it's definitely a 6C4 that goes in that spot. I didn't make a mistake. I operated this radio successfully and then just turned it off and went away. And came back this morning and without doing anything to it. That's in. She burned up. Now the resistor itself could be responsible. That's the least likely situation here. You know what? I cannot explain how this could possibly happen. It's just a grid. There's no voltage being applied here at all from anywhere. It's just a grid here, a crystal here. The tube had a short and the short has cleared. And now I've tested it. It's short on this tube. It could be a short up here. The 6BE6. Didn't I say something funny about the 6BE6? That's this tube. I got the wrong. No, again, how can I have the wrong tube in? The radio operated. Okay. Did I get the right one? 6BE6. Let's test this one. BE6. I got my fingers crossed that this is a bad tube. 6BE6. Here we are. 6.3. Signal level 4. It's very dark in here. 8L. 8L. 51763. 51763. 51763 and 3000. 41 C. Whole tube. Okay. I think if there's a short in this tube, that it would do a lot more than just, well, if it's just a grid. Let's look. Here we go. There's a short indicator right here. This is the one. And I ignored it. Because I thought, oh, it's very, very high resistance. It went away. Appears to have gone away. Normally with this tube tester, when you go from this position here, tube test, and all the way over to position 1, in both cases the meter normally rests right on 0. In these 3 positions, or 4 in between, the meter tends to come up just a little bit, and that's just does it every time no matter what tube I'm testing. But in this case, when I reach position 1, it doesn't relax all the way to 0. It stays up a little bit. That's different. Let's get another 6BE6 in here and see if it does the same thing. And if I were to test it with a little tiny leak in it, the test may be completely invalid. 1570, so just above the halfway. Oh, you see how it went over? It went whack right over. I think this guy is the problem. Okay, I will feeling hope again. I'm going to go drink coffee and find a 6BE6. Oh, it's been about 15 minutes since the conflagration, but maybe 20 minutes, but wow, it still really stinks in here. So I was thinking some more about this. I turned the set on this morning. It did not appear to work right from the start. And so whatever was wrong right from the start. Now it could take a long time for a resistor like that to heat up, and as it heats up its resistance goes up, and when it really gets hot it might even kind of go a little crazy resistance wise and actually get even hotter, and so it's kind of a runaway sort of thing. And it could be yesterday I operated this radio and that resistor got hot but just never quite got all the way there. I operated for quite a while yesterday, half an hour or something like that. No apparent anything. The next thing is I noticed the volume control started becoming quite scratchy, and I commented that sometimes indicates DC is flowing through the control, and that would indicate a breakdown in a capacitor somewhere. And while I was pondering that, meanwhile this other circuit is frying up. How could the fry up over here with the crystal system cause the effect here? I don't know. It doesn't add up. I can't add that up. Unless the short was pushing strange voltages even further, the short in the tube. Well, I think the circuit is really quite limited here. A little dark in my shop. Let me plug my light in here. The cameras are very effective at compensating for light levels, and so it's not apparent to you when you're watching the video just how bright or dull it really is in here. It's pretty normal right now. So we trace this wire again and just make sure I haven't lost it in a crease or something. There's this on the page. I don't think so. I mean, it makes perfect sense where it's going. It's just literally an isolated circuit comprised of nothing but a grid, a resistor, and the crystal. How can you burn this thing out? Okay, so I got the 6BE6 right. Forget that. That's right, I was supposed to be looking for another 6BE6 because I was drinking coffee, got interested in what was going on here and how could this effect be related back to what? I don't know. Okay, I gotta find a 6BE6. I'm pretty sure I got a lot of them. Okay, got a 6BE6 here. Do I for sure have a 6BE6? I'm just... Oh, I don't see the label on this tube anywhere. Yikes. How do I know this is a 6BE6? It probably is, but not being able to read it. This one definitely is a 6BE6. Okay, I saw a little clicker there. So now the curious thing is, will this tube also, in this tube tester, result in the pointer coming off the 0 when this is set to 1? I've never seen it before, so... Okay, any shorts. Here we go. Okay, now this should, you may not be able to see, it should relax to 0. There it goes, right down to 0. So I think the other tube really did have a short in it. Now, how's this tube for goodness? Let's check the goodness here. 1570, so up above halfway is what it's got to be. She's a fantastic tube. Wonderful. Okay, I'm going to put this one in. Now what about the 22 ohm resistor? Would you believe that could still be, or 22K, that could still be 22K, even after burning? It's possible. I mean, this thing smoked up pretty good, so it's not very likely. But what a smell. I stick my nose over top of it, yikes. A smell I have smelled many times in my in my life. So we're going to stick the ohm meter on there, or try anyway, and get an ohm meter reading. Okay, please bring back the light. It's way down there. Voltmeter, please. Anybody want to take a guess as to whether this is going to be good or not? Okay, a good place to put the meter would be right here. That's not a very good place, but we're going to put it there. It's supposed to be 22K, 60K. Now, okay, this is in circuit, but it's not much of a circuit. It's one lead, here goes the other one. So what is that? That is 170 ohms. So now, so the crystal is in parallel with this resistor. Does the crystal have a resistance? If you measure a crystal with a, I happen to have a bag of crystals. Where's my bag of crystals? I have a bag. Well, I can't spot. Here it is. Bag of crystals. My wife's going to ask me, what happened downstairs? Burned something up. I would expect these things to be open circuit. Myself. 6 million ohms there. What's that? What are you doing there, cat? Okay, so I got my fingers touching it. I have my fingers touching it. So look. Well, something wrong with this crystal. Incidentally, if you put a crystal in here, now this one is for, well, that's interesting. 13.5426 looks like. But the radio won't tune this frequency. It's going to tune this frequency plus or minus 455 kilohertz. Something like that is going to happen. It's just open, just what I was saying. So can a crystal short? That wouldn't even cause a problem. That would be shorting across the resistor. It would protect the resistor. So looking in the circuit again then, and so I've made a reading across here, and I get 170 ohms. So the other thing too is when these resistors burn, my experience anyway, and I don't have a lot of experience with this, is they go up. They don't go down. They just go up. So the crystal was shorted? I don't know how that could be. I'm not going to be able to get at it. I'm just really lucky it's the resistor that burned. Like the coils are in a different circuit over here. It's only one coil. It looks like there's a couple because there's two adjustments here. This doesn't even show this is adjustable. Am I looking at the right thing? Where's the, like there's this whole control and stuff going on. It's not reflected on here at all. I'm not looking at the right thing, am I? Am I? Crystal phasing, crystal oscillator. You know, it may not be the same thing. Oh, just what are the chances that there's a 22 ohm resistor in the other? Where would I find another thing? Crystal oscillator. You know, this is probably it, because you know this is just changing the literally the phasing of the oscillator a little bit. I don't see any variable adjustments here. Something's going wrong. I am off track. You're off track, Jim. let's just go see if I can find something else that might. I don't see anything else. What are you doing there, cat? What are you trying to do? No, 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 no. No, don't go up there. This is Wally. He's not the usual cat you see in here. See, he has a white patch on his back. So he's not as versed getting around the shop here as his brother is. Is that right, cat? Well, I don't see any other crystal in here. This one here, right there. Crystal phasing. Oh my God, Jim, you really blew it. Boo. Okay, 22. Okay, there is another spot with a 22. Okay, I blew it completely. Looking at the wrong circuit completely. Okay, well, this all gets really bad now because I see to burn this, you have to drive a huge current through this coil. And it's coming off the plate here. This is all making a lot more sense now. Because usually it's plate current that gets into things and burns them up. So we have two tubes. The plates are actually connected together there. I never really noticed that. This goes over. The plate current is flowing up through here. This capacitor has failed. That would be my guess. This guy failed, put a short on, and then the power supply just cooked this resistor away. The coil's okay. Nothing bad has really happened. Got to get this capacitor. Notice it's outside of the box. Oh, this might be easier than I would expect. But I look underneath the this area. Just looking for where do they show the adjustment? That? No, rear apron. No, rear rotor. Rear rotor. Crystal, non-crystal. Front rotor. Like, is there another 22 ohm resistor in this box? I don't think so. I think it's the only one. 2200. Okay. So when I measured this, though, I got, well, it doesn't matter now. Look at the circuit it's in. It's in a complicated circuit, and this thing's shorted, so we got to find that. C108. We have to see C108. Okay, that's the goal. C108. So I've been studying the complex array of information that's available for this radio and the various models of this radio. And it is complicated. What I've learned is when I bought this radio in 1977, I was handed this manual here, which not in this binder, just paper manual here. This is a American Air Force manual. Turns out this is one of the best manuals you can have, with excellent descriptions of all the circuits and fantastic diagrams all through it, explaining in detail and information that's not available in other places, like here, resistances of coils and whatnot. So I didn't know it at the time, but when I bought this radio, I was gifted the best manual to have with it without knowing it. I didn't know anything when I bought this radio, other than my friend said, go buy it. Not this radio, but one identical to it that I've had basically my entire adult life. And why am I looking in here now? I'm looking in here because I want to find out where we're going to find the 108 capacitor here. I should have gone through this on my own. Here we are. So these are the exploded diagrams, and it's down under the front near the meter. This is the bottom, so we're looking up. This is the front, and hard to tell what I'm looking at here. So I think over here, so we're looking for C108. There it is, C108. Somewhere right in there. Right in there underneath the band, underneath this structure here. Yeah, they're all lined up. Okay, now next step, tip this radio up. I think I'm gonna tip it up. I think I'm gonna tip it up this way. It'll be resting on its back. Okay, got nothing connected back here, nothing, just the power cord, but even that's, because the back of the radio can sit on these, you can do this. But I'm on this round thing, which is only so big. Pull this whole thing forward. I have to plan this out, okay? Because you can't get halfway through turning one of these and then realize, uh-oh, well, you got 60 pounds in the air. When I pull it forward, this may come forward with the radio, unfortunately. Nope. Good. All the way to about here. Up you go. Now we gotta... Oh, what's all that stuff? Let's come out of it. Okay. Jackpot situation here. There we go. There we go. What's all this stuff? And this stuff has come out right in the same area. And this is the circuit I took the box off of. And that's probably the capacitor right there. Can you even see it? Ooh, right there. What's with my camera? It seems to know things. Now it won't do it. Okay, more light. So I see a couple capacitors. So one of the things about these radios is this has nothing to do with what I've been dealing with. Something totally different now. This strip here that you can see with soldered wires to it. Apparently, this is a key point in these radios. This is the E13 connection block. In the early radios, it's like this, and this is fairly easy to work on. Apparently, in the newer radios, this is no longer open. It's now some kind of block, and I don't know what they're talking about exactly. And by the way, this is a huge capacitor here, and a huge capacitor here, and another one right here. And these guys in my other radio are good, and they appear to be good in this one too, because I didn't notice any humps just before it caught fire. Okay. So of the two capacitors that are down in this area, I'm guessing it's going to be the one. Oh, there's another one even deeper up. Oh my gosh. Yikes. Let's take a look with the closer up camera here. Let's see what we can see. Plan out. Dude, I'm going to start doing this. There's a whole bunch of capacitors in here. I mean, like look. There's one there. One there. They're all underneath the bandwidth control. This is the one that's probably the short. There's one back in there. And there's one up here. And you can see one way back in there, which this one, oh my gosh, this one could be the faulted one, and look where it is. Yeah. Well, I'm inclined to start changing capacitors all over the place here now. But I didn't want to make this into a project just yet. I really wanted it to be operable now. And I'm also going on the theory that there's a defective capacitor there. We better get some truth in here. My assumption is no capacitor will show a short, even though it's in circuits. It just won't show a short unless there's a short inside the capacitor. So we will prove that out by testing a bunch of capacitors right away. So, you know, is this guy shorted? Yes. It's right on a coil. Let me put this on 600 ohms. I'm testing my theory. Theory's not holding up at all. Is my voltmeter battery getting low? What's it doing there? It's all about the meter now. Never can make low resistance readings accurately. Well, all the way down to 0.1. Thought maybe this is the short capacitor. My theory just went right down the drain, man. Okay, let's try another one. That should not be shorted. These are all shorted, maybe. Like a radio full of shorted capacitors. There's another one. Oh no, that's open circuit. That's what I expect to see. Okay, let's go for the bad guy. Let's see, my camera's doing its thing. So this might be the bad guy. How am I going to know now? Because the well, that's not shorted. Okay, and it could be this guy. You know, I could look at that diagram again and see what it says about who's who. How about this guy? No, short. Check the meter. Okay, the last guy way up in there. The worst one of the bunch. I can't even see. I can't see. Holy smokes. If I look like I got very short, it's because I'm down on my knees here. I think there. I really can't see what I'm doing. There comes a cat. Where's my flashlight? I've got my super blaster light here. Thank you again to the person who sent me this little flashlight and told me that I'd probably use it every day. I use this flashlight every day. It is incredibly powerful. So, okay, burning my own eyes out doing this. That's good. And I think on the camera this tends to put some kind of a Venetian blind effect on the camera. I don't see it. How come? Using a different camera these days. Okay, that's it. It's not shorted. Oh, there's another one here. Okay, this one here. There's capacitors everywhere in this radio. This one. Come on, man. One of you guys got to be shorted. This one? Maybe that's the one. Did I really mess up? No way. No, it's up in this area. Okay, let's look at that diagram again. Hello, Bert. How you doing today? Having a good time? Looking for something to do, aren't you? Yeah, looking for trouble. Okay, back to that diagram, which I foolishly closed the book on. Here we are. Okay, so in this one, it's not showing. Yeah, see, you can't see that whole diagram here. So this is a different. C108. Didn't we see that pretty quick? I thought I saw it pretty quick here. See, more diagrams. C108. What? I didn't just write this. This has been in this book for years. See, I've visited C108 before. That's really okay. Maybe for some reason C108 is a problem capacitor. Where are you? I thought I saw it over here. Like it's got to be in this area. don't see it. More? Top. So this is top. There's the bottom. I'm afraid you can hear that my door's open here. You hear the TV playing in the rest of my house here. What happened to C108? Where did you go? It's towards the front. It's towards the front. Should be right in this area here. But man, I just sometimes you gotta wonder about me. Okay, C108. I'm having a conniption. C128. Is that what happened? I'm looking very carefully now. So it would be up in this area here. C108, there it is. Okay, C108. Now what is it pointing at? So I got myself turned around. C108. Wow. Really? You gotta try to figure out what that's pointing at. So there's a capacitor going this way. I can kind of see it in the image. And I can see it looks like a wafer here on the switch. It would be below the wafer. So you're coming in on the control. This is probably the coupler. I'm not sure. This might be the coupler here. It's hard to tell in this picture. And then 108, I think this is the first, yeah, see this piece looks the same as this piece, looks the same as this piece. So this is the this is part of this control support, and the capacitor is basically just below the support. Okay. Really, let's see what we can see here. The capacitor in question, just below. So this is the so the coupler's way up in here. So I think this is the support we were looking at, and the capacitor would be that one right behind it, and that's right in the right position for everything. That really does make sense. What doesn't make sense is the test. Okay, so there's the Venetian blind. Oh, stop. You can see curtains coming down a little bit. You can see my hand is. Okay. Digital flashlight. Let's try this resistor again. I'm just going to back you up here so you can see the meter. Okay, I'm going to take the elevator down one floor. Here we go. You can see very clearly the terminals here. Let's check the meter. Nothing, eh? Really? Come on, you have to be shorted. I'm commanding you. There it is. See, I had to command it. That's the guy. He's the guy. So I can probably change that out with some back-breaking effort here. How big is it? I don't think they wrote the value. Yeah, they did. The value's on here. Good. So looking again, the burned resistor, shorted capacitor, fault current through the resistor. It's a 0.02, 0.022. 0.02. Okay. I'm going to take a little break, and then we're going to do that. Repair.